Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL R3, which is trigonometric ratios in similar right triangles. So you're not going to see a lot of new stuff here compared to the last couple IXLs. The point this IXL is trying to get across is the ratio, specifically the trigonomic ratio, between two right triangles like this is going to be the same across both triangles no matter how big they are. As long as they are similar, the ratio is going to be the same across those. So, for instance, this problem is asking you to find tangent of angle I. So we'll go over here to the second triangle. See, angle I is right here. Okay. And to do that, remember tangent is going to equal opposite over the adjacent side. Okay, and if you need a refresher on SOHCAHTOA, you can always go to Khan Academy or something like that. Okay, there's a million different resources on the internet. You can see down here, tangent of a certain angle is going to be the opposite side, of the angle over the side that is adjacent to whatever angle you are referring to. Okay, so with that in mind, that means we are going to do the opposite of where I is. So right here, which is going to be HJ, and then over the adjacent. So this side is the hypotenuse, so we're not touching that. So we want to touch this side right here, which is HI. Okay, now we don't have any numbers here, and that's fine. So what we'll do is we'll go over to the left triangle and we'll do the similar side. So what is similar to HJ? Well, very clearly that's going to be FG right here. So we're going to pull the 21 and make that our opposite. So we're going to go 21 over our adjacent. The adjacent again is going to be HI, which looks like EF is going to be our correlating side. So it's going to be 21 over 20. All right, and we can't really simplify that down anymore. So we were just going to type in 21 over 20. Okay, next. This question is asking for sine of f. Okay, so remember sine is going to be opposite over the hypotenuse, the SO in SOHCAHTOA. Okay, so we're going to go, it says sine of angle F. We're going to go over here. This is angle F. And so we want the opposite over the hypotenuse. Remember, the hypotenuse is always the opposite side of where that 90-degree angle is. And so now we are going to go over to the left triangle and see what side is going to be similar to EG. And that looks like it's going to be CD, so 39 is what we're looking for there. And then over the hypotenuse of this triangle is going to be 89. Okay, and there we have it. It's going to be 39 over 89. over 89. There we go. Okay, now we have one here for cosine. Now we will do cosine. Okay, so remember cosine is adjacent over the hypotenuse. Okay, so we're asking, or it's asking for cosine of angle B. We'll go over here, angle B. And so we want the adjacent side here over the hypotenuse, this side, so right here. Okay, we go over to our second triangle and we see that EF is going to be similar to BC, so which means we're going to pull that 4 and put it over the hypotenuse. The hypotenuse, again, is always opposite of the right angle, so that's going to be 5. So 4 over 5. 4/5. Okay, and so I'm going to skip a couple levels. I think you get the idea, and I did one of each ratios. Okay. Okay, so don't be fooled by something like this. These two are definitely going to be similar triangles. Okay, so it's going to ask you to find I right here. That just means J is going to be the corresponding angle, and so on and so forth. Okay, we have another one here. Another one there for 85, and go all the way to 97. And we have another one. So I will complete this one just because it's in the 90 level and it's a little more practice. And the only difference is you might have noticed when you get up to the 90 range is instead of asking for just one of the ratios, they ask for all three. Okay, so it's asking for a sine, cosine, and tangent. I'll write down all three of those here. We have sine of x equals the opposite over the hypotenuse. We have cosine equaling the adjacent over hypotenuse. We have tangent equaling the opposite over the adjacent. Okay, so we are doing all three of these from angle F, so we'll go to angle F, this one over here, and now we want the opposite. So the opposite, when we compare both triangles, is going to be this side, this entire side right here, right? And since this small triangle is just a similar triangle to the large one, we know the length from C to D is going to be the corresponding side, which means 15 is the side we want. Over the hypotenuse, again, we want the hypotenuse here, and 39 looks like it's going to be the corresponding hypotenuse to the smaller similar triangle, so that's going to be 15/39. Okay, the adjacent is going to be our 36 over the hypotenuse, which is 39. And then the opposite, again, is going to be 15 over the adjacent, which is 36. Okay, so let's type those all in. We have 15/39. And is 15/39 something we can simplify? Yes. So 3 goes into 15 5 times, so we'll divide both the numerator and the denominator by 3. So 15 divided by 3 is 5, and 39 divided by 3 is going to be 13. Okay, can we simplify further? No, we cannot. Going to cosine. Cosine is 36/39. 36/39. Is that something that can be simplified? Yes, we can divide both sides by 3. So 36 divided by 3 is going to be 12. And 39 divided by 3 is going to be 13. Can we divide that any further? No, we cannot. And then our last one is 15/36. 15/36. Can we simplify that at all? Yes, of course. We can still divide both the numerator and denominator by 3. So 15 divided by 3 is 5, and 36 divided by 3 is 12. Okay, so can we simplify that any further? No, we cannot. So that is going to be our answer. Okay, and there you have it. So this is where I'm going to stop the video. Study hard, stay safe, and I will catch you for the next IXL tutorial video. Goodbye.